So good morning, everyone. So we have discussed about what is workflow, then why Snowflake, Snowflake architecture, and multi-cluster warehouse, shared disk, nothing shared architecture, and micro-partitions. Then today we're going to discuss about cluster. So this is very important for the performance tuning. We use the cluster key. So today we are discussing about cluster key. Okay. So first bank domain. So workflow we discussed. Snowflake architecture and mm, shared disk, okay, architecture and nothing shared disk architecture. Okay, Snowflake uses so combines both combined architecture, okay, architecture and micro partitions we discussed. And today we are discussing cluster key. Clusters key we're going to discuss. So what is cluster key? So we know, right? So when we create table and we insert data, so that going to store in the format of micro partitions. So micro partitions. But in Snowflake, it stores like, but when you have large table and if you are running query, okay, you are like working with 1 second, the file is not up. When you are running a large query on the like query, you are using one column name multiple times. Okay, you're using one column, so multiple times. So here, what is happening? It's taking delay, right? If you have a large table, like 10 million records, okay, in that table, if you without applying cluster key, if you run the queries, it's take delay. Okay, so take time and cost. Okay, so here we have cluster key. So micro partitions and cluster key and recluster re recluster. So we have these recluster cluster, you can call this one. Okay. So we're going to use, we're going to take a bank use case. Okay. We're going to discuss theory, bank use case, when, why, advantages, limitation, cost, certification, certification question and answers, and interview question and answer. So, uh, and medallion material layer. So about and we're going to discuss. So we already discussed about what are the micro partitions. So every table in Snowflake is automatically cut into small immutable storage units called like micro partitions. Roughly 50 to 500 MB of uncompressed data, each about 80 to 8 to 16 MB compressed. This happens automatically the moment data is loaded. So there is no manual partitioning like Hive, Oracle, or Bank like Hive or Oracle. And think of a table as a hoop bank vault. Instead of throwing all cash into one gained room, Snowflake automatically packs it into thousands of small lockers. Those are micro partitions. Each locker also gets a label on that outside listing what is amount and who is the customer for whose amount like that. So what's inside? So the min and maximum value of every column stored in that locker. So column storage inside each micro partition only required columns are read. So metadata stored per partition, min max per column, distinct value count, null count. So immutable, any update or delete. So merge rewrites the affected micro-partitions. It never hit in the place. Okay. So I will explain what is a mutable and immutable. And the optimizer uses the min and max labels and to skip loggers that cannot contain the answer. This is called partition pruning, query pruning. So pruning is why Snowflake can query terabytes in the seconds, right? It's going to run. So it never opens most all lockers. So this thing is how it works. And here we have mutable and immutable in the software. Mutable and immutable. So immutable. Immutable. So I'm taking one record. So ID is 721. ID, name, and salary, city. Now ID is 721. Name is like Ravi. Salary is 120,000. City is Hyderabad. So now it going to store in Snowflake immutable. So immutable moves. See, now we have ID Ravi salary Hyderabad. So now anything. First we go to mutable. If think data is mutable, okay. Think data is mutable here. Copy this. So now what's here some update in the immutable. So Ravi moved to Bangalore. So Ravi moved to Bangalore. Okay. Uh, then Bangalore. Then he's got he got a hike. So like now it's like 1.5. So now what is happening in this mutable table? So immutable table. So Ravi moved to and it's going to all ideas change. ID also change. Change. So like I to one. Okay. So now the different company, move different company, ID change. Okay. So now what are the updated these values going to overwrite the data. So overwrite the data and you want to overwrite these data and you move to Bangalore. Okay, this one. So in mutable, see in mutable. Okay, so this one going to update. Okay, so immutable. So these row, these values going to overwrite these data. So it overwritten the I2 So Ravi, same 150,000 Hyderabad to Bengal. Okay, it means so these row going to delete from the table. Okay, when the mutable. So it's this value, this record overwritten this one. So this thing. Okay. So this is like mutable example. Now we go with immutable. Mutable. Here what is happening? So we have same. Okay. We have same. Okay. Same thing happened. Ravi moved to Bangalore. He got hike. Okay. She got a hike. 1,50,000, 30,000 hike. And idea also change later. Now what is happening here? So we have same data, mutable, right? Immutable. So we take this data. So immutable, what is happening? Happen. So it's going to update the 8 to 1. Salary going to update 50. So, okay, this is the record. So this is immutable. So now it will not overwrite the data. So it's going to create one more row of record for Ravi, and he going to uh, so this one value. Okay. Here it goes. What is happening in Snowflake? It's not overwriting the record or any updates. It's not overwriting, so it's going to be inactive. Okay. This is going to be active like this. This is inactive, and this is going to active. It's not going to overwrite, but in mutable it overwrites immutable. This one overwrites this one. Okay, but in Snowflake the data is in the immutable, right? So that's why it's not overwrite. It's going to create one more row. Okay, this record going to inactive. Okay, and this record going to active. Yeah. So this is how Snowflake handles the data when it loads in the Snowflake. Why this is immutable? Any guess, anybody? Why immutable data in the Snowflake? Why why data is immutable in the Snowflake?
Because data is stored in micro-partitions.
So okay, that's data stores fine. Why immutable in the Snowflake? So in other immutable, right? Why it's not overwriting? It's going to be inactive and it is going to be active. Session be like interactive.
Implementing SCD2 type.
No, not like. Yes, that's only fine. Not that is not. So in Snowflake, we have the time travel feature, right? So that's why
Yeah.
the data is immutable in the Snowflake. Why? Because of so after few days, if it overwrites, so I want to see these data, previous records of Ravi, I am able to find if the data is mutable. But if data is immutable, it's inactive is active, then I can see Ravi's history. Okay, when he working in the Hyderabad, what is his salary, what is his ID, and so like that we can see ID and salary. Okay, what is then what we have given the hike to him. Okay, we can see what is previously where he worked in Hyderabad. What is salary? Okay, 1,20,000. Now what is the hike we given? 1,50,000, 30,000. And now city he is working in Bangalore like that. Okay, so that's why we have time travel feature. Up to 9 days we can recover the data if anything is deleted, and also if after 9 days completed, still we have the fail safe. Okay, to return the data, but we don't use failsafe. We need to contact the Snowflake support. Then there will be a customer team of Snowflake company. Then they go into data Snowflake engineers. Then they will discuss, they will create some database schema, and they will provide the if any data is deleted. That's why data is immutable in the Snowflake. Okay. In others, they like mutable. So we have mutable and immutable. So while you are explaining about the architecture, you need to use words. Okay. You're going to store, okay, like immutable in the Snowflake. So this is clear, right? Any confusion with this concept? Then we go to cluster PPT. It's okay.
Madhu, can you show me that one example, mutable and immutable?
Example.
I mean, you already wrote that one, right? The records, ID,
Yeah, this
names,
is
all.
this is example I given. So first, one second. First, in Mutable, Ravi is working in Hyderabad. His salary is 1,20,000. Then Ravi moved to Bangalore and he got a hike, 30,000. Now present salary 1,50,000. So also the ID change. Now, so this what is updated, it going to overwrite the this record. Okay, this is mutable. But in Snowflake, it's not overwrite. Okay, even the updates, it going to create one more record. Okay, and previous record going to be inactive and this is going to be active. Clear? This
Okay.
this
Okay.
example I given, right? Okay,
Yes,
see,
yes.
yeah, this is an example. Say it overwrites the it not overwrite. Okay, mutable
Mm.
overs the data, immutable not overwrite. It's going to inactive. It's going to create new record. Remember like this. So anybody others? Please be interactive. Shiva, Raghu, Sam, Sandhya, Shabbat, Shiva Reddy, Venkat Prasad. Then you can learn more. Please interactive while session is going. Okay, clear, right? And I'm also not getting more if you feel. Okay.
Yeah.
Okay.
Can we say this point in cloud service layer?
Yes, yes, you need to say immutable. Okay, whenever you're explaining about the architecture and micro partition, you need to use both these words. Okay, you need to
Oh,
use. Yesterday I taken, right, so I have taken first time that I know, but I have taken first time that shared disk architecture, nothing shared architecture command Snowflake, right? Use first start with shared disk, not shared disk, nothing shared disk, multi-cluster, then about while explaining about, then include this immutable. So if you go with like, they will think, okay, you have good knowledge on Snowflake and you have work good, you have real time experience, work experience. Okay, like that. Okay, so because of I so given many interviews, very good final round. They keep in the hold. So I checked with the that HRs and other. So what they're saying, even we give out of 10, 8 out of 10, 8 given good in the interview. We out of 10 questions we are answering, right? That's good. So they need to select, but still they are holding. By holding, so the next person they're going to take it to the other side. They are giving best chance. Okay, so that's why still they are holding our profiles, right? So to avoid that, so what I'm doing, the answer should be like your what you have in the resume related to that only, not from outside. What you have in the resume. Suppose you have healthcare domain, retail domain, power domain, and any other business domains. Now, our bank domain. So stick with healthcare domain and bank domain, and out of other USA, UK, New Zealand, go with power project. The power project that is best. Power and the bank in India, healthcare bank in out of India, still go with bank and power project. Okay, that I will give you everything. Okay, this bank going to work on this bank domain in this current in this one. After next we go with the power project. Okay, but everything same, everything is same. What are we are doing practical theory? Table, the data needs like table names, columns. Requirement is different. The requirement is different. Okay, everything is same. That's it. Okay, that's why answer should be like experience scale, not like definition. Okay, not like definition, like experience. Okay, so if you know something about anything, okay, just go with Cloud ChatGPT, paste it, okay, and give answer like talking to the discussing with the interviewer. then it will give follow that. Okay, with good vocabulary, use words, whatever we are talking, when we use good words, right? Related to professional words, related to subject words. So it's going to, so like that. Okay. So okay, this clear, right? So we will discuss everything. No worries. It's going to waste time to discuss now. We need to complete cluster key. Tomorrow we're going to create the account, Snowflake account. Okay. Mm, can I move to next one? Can I?
Yes.
Yes, okay. So, what is cluster key? What is cluster key? Anybody have idea about cluster key?
Yeah, cluster key is a key factor to improve query performance. It reduces the scanning of all micro partitions.
Yeah. Mm, okay. Anybody? Anybody? Okay. I will go with.
Query performance is slow even after sizing up warehouse.
So next, yeah, correct one, good one. So we take one table, bank transactions, okay, bank transactions table. So here we have the columns. Okay. So one is like uh, transaction transaction ID, and then we have customer ID. Then we have branch ID, and then we have transaction date. Then we have amount. These things. So bank transactions table. In that table, you have columns: transaction ID, customer ID, branch ID, transaction date, amount. So these are we have. Okay. So next, before cluster, how data looks. So before cluster key, before cluster key, uh, data loads. Okay, data loads are random, so not in organized way, random. So see micro partition and uh, how it stores data store. These are the micro partition. Okay, and how the data is stored. For example, see partition one, micro partition one, data stores like, see jar, and take March, and then August, then December. Then partition one, go with partition two. Here are the stores. Here we're going to have paper, and then again on July, then again on October. Okay, partition. So, take Okay, sir. Okay. Okay. So we're dropping things that partition 3 here, partition 3, and here how it stores. Here we have the data like again, see John, again April, then we have September. So final partition 4, you have like May, and we have June and December. So this is okay. This is why the data stores in the Snowflake like this, like this. When we have not uploaded this thing, okay? So without a cluster key, okay, without cluster key, the data like stores like in the Snowflake. The data stores like in the Snowflake. Okay. Partition 1, partition 3, 4, Jan, March, August, December, February, July, October, January, April, September, May, June, December. If I apply this, now I'm running the one query on this table. So select from bank. Okay. Table name is bank transactions. So here way class we are using transaction date. Transaction date equal to here 2026 and 011. Okay, this is code. Select our bank transaction, made transaction date to the is January 10th. So now what is happening in the Snowflake, inside the Snowflake? Okay, so Snowflake cannot determine which micro-partition contains the January data. Why? Because of you can see in here we have the January, and here we have the January, and partition 1 and partition 3. Okay, we have the January value. Okay, here Snowflake cannot determine which micro-partition contains January data. So what is the result? It scans partition 1, partition 2, partition 3, and partition 4. So almost all micro-partitions are going to scan. Then what is happening here? It's taking the time and cost. Okay, more cost. So after creating cluster key, so are we going to create a cluster key? There are two ways. So while creating the table in that syntax you can mention, or if you're not created while creating, if not created when you are creating the table, if you are not created, so we can create with while creating the table, or if you're not created with the table, then we can use alter table. Okay, bank transactions here cluster by, so here must, okay, transaction date. This is the alter table bank transaction cluster by transaction date. Now the cluster key applied on the table. So now see uh, after creating cluster key, this till now move next step. Okay, so we applied the cluster key on the table, alter table bank transaction. Okay, and cluster by transaction date. So the cluster key is defined, but exiting data is not immediately reorganized. The table looks like this, okay, or like different. Okay, see. So now the cluster key is defined, but exiting data is not immediately reorganized. Okay, so how the table going to look like? See, maybe. So we have right January, December, February, July, October, Jan, April, September, May, June, December. Okay, say it will look like this one. Okay, so after playing, the table look like this. So query performance is mostly unchanged at this point. Here, the query performance mostly unchanged at this point. After, okay, so after automatic reclustering, Snowflake rearranges the microparts in the background. Suppose think, so it's not now it's not or rearrange. So what we need to do, okay, third one is after, so automatic recluster. Okay, so first we apply the cluster key in the transition date, but still, okay, the cluster key is defined, but exiting date is not immediately reorganized, not reorganized. So after automatic reclustering, Snowflake going to reorganize the micro-partition in the I will type it. So in this way, how it going to be? See, now we copy this. And now it's going to be, so in B1, so you're going to have January, and in B2 going to have February, Feb2 can be February, April, and April. And MP3 would have, okay, May to August, and MP4 is in partition 4. Now we have like September to December. This is a partition 4. And now the same query for our query, right? We have the same query, and if we are the same query. So Snowflake reads only partition 1 and skip the other micro partitions. Why? Because of January we have the partition 1 only, but here January in the partition 1 and partition 3. So Snowflake, that we don't know Snowflake where it is located, but now we have applied cluster key that in partition 1 January. So when we run the query, Snowflake reads about the partition 1 and skip the other micro partitions. So here what is the benefits? So here benefits like fewer micro partitions scanned, faster query performance, lower compute cost, better partition pruning. So what is the summary? So before cluster key, data is randomly distributed across micro partitions. After cluster key, the clustering rule is defined, but old data remains unchanged initially. But after reclustering, Snowflake physically reorganizes the micro partitions based on the cluster key, improving query performance through efficient partition pruning. Okay, so this one clear, right? After applying the, so it's not scanning all partitions, scanning only the January. Is it clear, guys? Any doubt? Okay, guys. So mother left due to the time, so I have started delay. Tomorrow I will start only 8 a.m. So we will continue the class tomorrow because of they are sending the message to me to my number. Okay, we will continue the class. Okay, because they need to attend the live classes. We will continue tomorrow.